Hey JEE warriors, welcome aboard to the JEE 2024 Magnetic Effects of Current, your electromagnetic induction and alternating current, EMI, all these chapters, questions which we are going to discuss based out of NCERT. So there are some important lines, there are some important definitions, important formulas, important words which you are supposed to know from NCERT, because NTA picks up directly from NCERT many questions and you will see that they get repeated too. It will not be just useful for your JEE 2024 but also for your board examination. So this is your Captain Shreyas, your physics master teacher, going live, and I have been pushing kids, I have been sending kids into the top-notch colleges in the country for more than 10 years, and here I am to send you to this year. So let's begin, let's get ready. If you are new to the session, make sure you are subscribed to the channel. If you are a regular user, regular member, then you know what to do. The daily ritual, smash the like button right away right now. Nice to see all of you. Hello Bhaskar, hello Badrinaran, hello Priya, hello Charan, hello Chuk Puchuk. Yes, let me also tell you one more thing. There are two more announcements which I need to make. First announcement. There is a fake circular which has been sent to many students or many Telegram groups claiming this is from NTA, and new dates for provisional answer key has been announced, and you know the new answer key also has been announced and all of that. That is fake. Don't believe it. Number one. Number two, we are going to do something exclusive for JEE in this coming week. You will see a new mini series which is going to come up for your JEE preparation, and we will do all those chapters specifically which we did not do in probably the flash series, or maybe we did it in the flash but we need more practice. So those kind of chapters, let's pick it up. What say? Okay, so get ready for it. Yes, things are going to come up, things are going to get really hot in the coming few days, but simultaneously remember we have to go through NCERT too. Okay, so let's begin with the questions. All the questions will be filling the blanks. None of the questions will have options. That will power up your brain. It will warm up all the neurons, because you will start thinking about what is the best fit option over here, because none of the options are here. All right, so I want everybody to spam in the chat box. Is my voice clear? Sukrita, just check it out if it is clear. Okay, one second. I think there is some issue with the mic. One second. Just check it out right now. Just check it out right now. Now is it fine? Just check it out right now. Just 1 second. I don't know why it is coming. 1 second. Hello everyone. Am I audible? Am I visible? Am I audible? Am I visible? Let me know now if it is fine. Hello everyone. Am I audible? Am I visible? Again, same issue. Am I visible? Hello dear students, just check out my voice right now, if I'm audible properly, if I'm visible clearly, if there is no resound coming. Just let me know right now. Now it is clear? Okay. Just check out my voice, right? Okay, looks like it is. Perfect. Okay, let's go. The magnetic field at the center of a circular loop carrying current is given by which formula, where R is the radius and mu naught is the permeability of free space, and magnetic field is mu naught I by 2R. Mu naught I by 2R, a lot of people write it as 2 pi R. That is wrong. Okay, be careful about it. So the formula is mu naught I by 2R, not pi R. Pi is there when you have a wire and you find the field around it. For a loop and the field at the center, there is no pi. Next, the phenomena by which a material becomes magnetized, temporarily becomes a magnet, okay, when placed in an external magnetic field. What is that phenomena called when a material gets magnetized? Bharat, let me tell you, NTA released the key. The answer key was, most of it was fine, 99%. The problem was with the order. If in the question paper it's question number 5, in the answer key it is question number say 15, and in the options are not in the same order. The options are also in different order. That is why the confusion happened. Otherwise 99% questions are correct. Yes, it is induction. No, it is called magnetization. A material gets magnetized. That phenomena is called magnetization, not induction. Induction is the process where a magnetic field creates electricity. Here, magnetic field is creating permanent magnetic phenomena, that is magnetization. The next one coming up on your screen, the force by a current carrying wire when placed in a magnetic field is given by what formula, where F is measured. Obviously, force will be measured in Newton. L is the length, theta is the angle, B is the magnetic field. It is IL cross B, right? It is IL cross B. Yes, Satyan, it is a JEE class, but many of the JEE students end up preparing for boards also. So I am simultaneously preparing you for both the things, right? Because or else what will happen? There might be some issues, like many students don't get qualified in boards, and some students probably just prepare for boards but don't prepare for JEE. So we need to keep a balance of that. Yes, it's just for these next 2 days. After that, we are going to have an exclusive JEE series, mini series for the next week, and then obviously after that we'll be doing whatever preparation needs to be done accordingly. Yes, IL cross B, but sine theta is also there. Be careful, not just ILB. ILB is when theta is 90 or sine 90 is 1. Galvanometer can be converted into an ammeter by connecting dash resistor in dash with it. Which kind of resistor do you use and in what? Yes, what kind of resistor do you use and in what? Yes, obviously you will use a parallel resistance. It's called shunt. It's a low resistance value. It's low resistance and you use it in parallel. Very good, many of you got it. Excellent. For voltmeter, you use a high resistance in series with it. Magnetic flux through a surface is given by phi is equal to what formula, where phi is the flux, theta is the angle between B and the normal to the surface. Many questions came directly in the first attempt, in the January attempt, just to find the flux. Such easy questions have come in first attempt. If you don't believe it, open up the answer key, the question papers, you will only find it for yourself, or see our discussions. Yeah, it is B dot A or BA cos theta. B dot A or BA cos theta, and the flux is always measured in Weber. Weber is the unit of flux. Electric flux is not measured in Weber. That's one common misconcept which many students have. Magnetic flux is measured in Weber. Next one. The force between two parallel carrying currents is attractive if the currents are in which direction? Perpendicular, parallel, anti-parallel? Yes. Sir, is distance of closest approach in portion for atoms? You can keep it in the portion if you look at it from electrostatics point of view, because at the end of the day, what is closest distance of approach? Like you have a charged particle, it comes very close, it loses the kinetic energy, converts into potential energy, and then it stops. So mechanical energy conservation is involved. Electric force of repulsion is involved. So both the concepts are there. So might as well study it, because they might always say you can solve it like this. Even if closest distance of approach is not considered to be in the portion or is in the portion, doesn't matter. Study it. Okay. Right. They are parallel or anti-parallel. They will be parallel or basically in the same direction. Yes, very good. Remember, same direction they will attract, opposite direction they will repel. Okay, this is exactly opposite of electrostatics. In electrostatics, same means repel, opposite means attract. Here it is opposite of that. Magnetic field lines in a bar magnet begin at the dash pole and end at the dash pole. Which poles do you think it is? Yes, come on, think about it. Yes, accelerate, I think I just mentioned it, right. The positive vibes, the thing is, NTA has taken back their answer key. So we are also waiting. See, we were working and now NTA has taken the answer key, and then we also saw that some of the questions ordering was wrong. Some, answers were also in the wrong order. So we are waiting for the fresh answer key to be released. So NTA has taken away that answer key. So we are waiting for that. Don't worry. It will happen by tonight or worst case tomorrow morning. Okay. Yes, South Pole to North Pole. Many people mentioned North to South. That is wrong answer. Be careful. How can it be North to South? Think about it. In a bar magnet, inside it goes from South to North. Outside it goes from North to South. So be careful whether it is inside or outside. So inside it goes from South to North. The unit of magnetic flux is, Weber, we just did it, or Tesla meter square. Weber or Tesla meter square. 1 Weber is when 1 Tesla of field goes through a meter square area. Next one, strength of a magnetic field produced by solenoid is proportional to the dash of turns and the dash. Two quantities. Okay, so these are rapid fire questions. I want everybody to participate, everybody to think. If you are not able to type, it's okay. At least the one thing you can do is smash the like button, right? Do that. And if you are able to type, very good. I will be very happy to see your name along with others. Okay. Yes. Okay, come on. The correct answer for this is proportional to, magnetic field is mu naught Ni. N is turns per unit length, is proportional to the turns, number of turns per unit length. Yes. And I is nothing but the current. So number of turns and the current. Yes, perfect. Magnetic field will not exert any force on a particle which is charged when it is moving dash to the field lines. The formula for the force is Q V cross B. So if the velocity is parallel or anti-parallel to B, then the cross product will be a 0. There will be no force. So it should be parallel or anti-parallel. Both will work. Parallel will also work. Even anti-parallel, no, perpendicular will be maximum force game squared. Be careful about it. Okay, moving on. Yes, positive vibes will be taking JEE exclusive classes also in the coming days. And let me tell you, these are NCERT classes which is going to be useful for JEE as well as boards. So don't think, boards are chill. No, don't take it chill. And don't say, oh my God, there is also JEE written. Oh, is it for me? Of course, it is for you too. So don't neglect NCERT, because if you neglect NCERT, then NTA will neglect you, marks will neglect you, rank will neglect you. Be careful. Okay. Opposition phase by an inductor to change a current is quantified by its, what is that property called? When you change your current, then there is some kind of resistance which is incurred. That opposition which you feel is called as inductance. It is called as inductance. Inductance always opposes the change in the current. Keep that in mind. Very good. Yeah, you can also call it as the inductive reactance, is the resistance provided by the inductor. So it's an inductive property of an inductor. Yes. Magnetic field inside a long solenoid carrying current. If you have a long solenoid, what will happen? The field lines are almost parallel. Till they come out on the other side. So it is mu naught Ni and it is roughly constant, which is uniform. Yeah. So that is the answer. It's almost constant. It is mu naught Ni, and at the ends it starts spreading out. At the end it is mu naught Ni by 2. Remember that formula as well. For a long solenoid, at the end the magnetic field is mu naught Ni by 2. Half of what it is there in the central region. Next one, the ratio of the flux to the current in a circuit is known as the circuits. Flux by current, what is it called? Flux by current, what is it called? Remember, flux is Li. So L is phi by I. So it will be L, which is inductance. Yes, L is phi by I because phi is Li. So that's the answer, which is an inductance. Next one. If you take the direction of the force on a charged particle and it can be determined using which rule? Right hand rule, left hand rule, some other hand, my friend's hand rule. Which hand, guys? No, not the Gauss law. It was the inductance for the previous one. Yeah, it is which rule? Which hand rule will you use? Yes, the left hand rule. ILB, QVB. So those formulas use the left hand. And when you have to find the EMF induced in a conductor which is moving in a magnetic field, you use the Fleming's right hand rule for BLV. So for BLV, you use right hand rule. For ILB, QVB, you use the left hand rule. Okay, so two different rules. Keep that in mind. Magnetic field by a solenoid can be increased by inserting a dash core inside it. So if you want to increase the magnetic field, you need a material which accepts that field and also increases it. So there are three materials. One is dia, then is para, then is ferro. Ferro is the one which increases the field by a very strong amount. Hence, it must be a ferromagnetic material. Very good. No, you cannot say metallic. Not all metals are good. It should be a ferromagnetic core or a soft iron core. Those kind of answers will be correct. If it is not ferromagnetic but just a metal, it will not work. The dash effect is the deflection of charged particles moving through a magnetic field. Which effect is the cause of the deflection of charged particles which go through a magnetic field? Whenever a charged particle goes through a magnetic field, the force it experiences is QV cross B, and if there is electric field, then there is plus QE force also. So these forces together, what are they called? They are just called as the Lorentz force. Hence the answer is Lorentz. Lorentz force, QVB plus QE. That is the total force. If there is only magnetic field, okay, only QVB force will be there. Got it? Excellent. Keep answering this. Some of you might be taking these sessions for granted also, saying, oh, I know these answers. But these are the exact questions where you lose marks and realize, oh, I didn't read the NCERT properly. Oh, I didn't read the theory properly. Oh, this silly mistake, I did it. And I took boards lightly, or I took NCERT lightly, and JEE mains screwed my life. It played with my marks. So don't do that. It's a time where you take a step back, where you actually realize what kind of questions can be asked in your JEE mains exam. Even the simplest of the ones. The measure of the field induced inside a substance relative to the external field is known as. When you take external field and pass it through an object, the field can increase, can decrease, depending on the type of the material, whether it is dia, para or ferromagnetic. So what is that quantity which tells you about, how permeable that material is towards magnetic field? That is called as magnetic permeability. You can also use other factors like susceptibility and relative permeability. That is also correct. But yeah, you can also write magnetic permeability is that one property. Even the relative permeability will work. So it all depends on the options. It all depends on the options which are there. So accordingly you will choose it. But permeability, relative permeability, susceptibility, all of them tell you about how good will the field lines pass through it, how good can it get magnetized. The device used to measure the intensity of magnetic field is called as dash meter. Remember, even in the first attempt, January attempt, there was a question on instruments, and many students felt like it was a bouncer question and they thought it was out of syllabus, but it was not. So expect a similar question in the second attempt too. So think about this. What is that device which is called? It's there in NCERT and other books too. What is used to measure the intensity, how strong it is? Magnetic field is measured in two units. One is Tesla, one is Gauss. So Gauss must be the answer. It's called as a Gauss meter. So Gauss meter measures how strong the field is. What is it called? Yes. Prachi, there are thousands of channels in Hindi, but there is only one channel in English, that too for JEE students. One channel. And that channel also, if you tell me, please teach in Hindi, what should all the students do who are learning in English? What should all the students do who cannot understand English? What should all the students do who are outside India and learning from us? What should all the students from Northeast, from South, and so many other, even Delhi and Mumbai students I know, and many other cities, they prefer, even if they know Hindi, they want to learn in English because they know at the end of the day, when you graduate, you will be going in companies, you will be traveling abroad, you need to converse in English, you need to be fluent in English. That's the reason why most of you might be, learning also things in English. And anyways, when you get into IITs, they teach you in English only, they don't teach you in any other language. So it's better to make that step ahead right now. Don't feel bad, but there are already many channels. So let's preserve this channel, and we need your support, in fact, right? So please understand that. Yeah, okay. The answer key challenge, we'll have to wait because they have taken the answer key. NTA is playing games now. They have taken back the answer key, so we have to wait for the new answer key. So let's just wait. Even the provisional answer key they have taken back. Don't worry, the date for challenging will also be extended. Don't worry. Okay, got it? All right. Materials with negative susceptibility, what is it called? Materials with negative susceptibility, what is it called? What is it called? Come on, think about it. Negative susceptibility means it is a diamagnetic material. Exactly, like water and many other materials. Yes. Small susceptibility is para, large susceptibility is ferro. Very good. Okay. A wire loop's magnetic moment is proportional to the dash it carries and its dash. Okay. What do you think is the correct answer? Yes, a wire's loop's magnetic moment. Magnetic moment, I had told you, remember the term, just like NTA, just remember NIA, National Investigation Agency. Everybody knows NTA. Nobody is there who does not know NTA now. Very famous. So same way, like NTA, what do you have? NIA, National Investigation Agency. So N is number of turns, I is current, and A is area. Turns, current, and area. As simple as that. Device used to measure the direction and the strength of a magnetic field. See, one of the previous question was to find the strength, the device is called as a Gauss meter. But to find the strength as well as the direction, that device is called? Come on. See, just measuring the strength, it is called Gauss meter. Measuring the strength also and measuring the direction, that is called as a magnetometer. Very good. Moving on to the next one. Many students do not know this, and if it comes in match the following or as JEE Mains simple objective question, you will be baffled, you will be awestruck, you will be like, what is this? I don't know. But you are attending my sessions, I am saving and preserving your marks. Ferromagnetic materials such as iron, cobalt, nickel become magnetized due to the alignment of. In the theory of ferromagnetism, you learn that there are certain regions where the magnetic moments are in a particular direction, and those regions have all the magnetic moments aligned in that direction, and another region has magnetic moment aligned in another direction. So when an external field is applied, all those moments which are in those directions of the field, they become larger and grow in size, thus retaining the magnetic property. Those regions where the magnetic moments are in a peculiar direction, which happens because of a phenomena called as quantum coupling, you get the magnetic domains. Yes, no, they are not electrons, they are magnetic domains. Perfect. The magnetic domains are those regions where magnetic fields are in certain directions, and the magnetic domains grow in size when external field is applied in those directions. Materials with magnetic permeability much larger than 1. See, if magnetic permeability is less than 1, it is diamagnetic. If it is slightly more than 1, paramagnetic. If it is much larger than 1, then it is obviously ferromagnetic. Very good. Moving on. For boards, this will easily carry some good amount of weightage because we are discussing 3 main chapters over here. So easily you can expect 30 to 40% weightage just from the board's perspective from these 3 chapters. The magnetic field strength at a point away from a long straight current carrying wire varies inversely with the dash from the wire. The formula is magnetic field is equal to mu naught I, which is current, divided by 2 pi r. So if you notice, r is there below. That means magnetic field is inversely proportional to r. So it is inversely proportional to the distance. R is nothing but the distance. Very good. Excellent. Very good. AMS, Ayush, Abhishek, very good. Bhaskar, very good. Game squad. Hello Sanjeev. Yes, your captain is here. Yes, Anka. Very good gaming over Tamil. Hari. Moving on to the next set of questions, but let me remind you one more thing. There are free mock tests, free boards exam tests in the description box. Please use the link which is there in the description box and make the best use of it. Okay, so go to the description box, you will see free mock tests. Just enter that link, enter your login details. If you have already created an account, you don't have to worry about it. If you're not, create an account within 1 minute, enter the OTP and get those mock tests for absolutely free of cost. Okay, as per the new board syllabus. So all those test series and CBT mode tests are available for you. Next one, AC current reverses its direction in a sinusoidal pattern, typically how many number of times a second in a 50 Hertz AC supply? Come on, think about it. What do you think is the correct answer for this? Sarah Grace, we will be taking it up very soon, don't worry. Alternating current reverses its directions in a sinusoidal pattern, typically how many times a second in a 50 Hertz supply? Come on, tell me. What do you think is the correct answer for this? See, in a one cycle, first the current goes like this, then the current goes like this. So it changes the direction 2 times. Once here, once there. But if I tell you 50 Hertz, that means 50 cycles in 1 second. Each cycle will change the direction 2 times. So 50 cycles will change it 100 times, 50 into 2. So answer will be 100. Many people write it as 50. That is wrong. Some people write it as 2 times. Some people write it as 25 times. That is also wrong. Options given will be 2, 25, 50 and 100. Students who mark 2 or 25 or 50 will get -1. If you mark 100, you will get +4 marks. So each cycle will change it 2 times. So 50 cycles will change it 50 into 2 times. That's 100 times per second. This is per second. Remember that. Okay. If you take a AC circuit, the phase difference between the voltage and the current through it is dash degrees. Come on, answer this question. Sir, we need to read line by line in physics book, or knowing the concepts and formulas are enough? See, there are some things which you need to know theoretically. Like I told you, the instrument used to measure this is called what? Or the lamination which is given on a capacitor plate which acts like a dielectric, which increases the capacitance. What is that layer going to have? It's an oxide layer. So there are certain theoretical things which you need to know from board's perspective. That's why I say NCERT line by line. What happens typically when we are training ourselves for JEE? We are mainly focusing on problems or just the conceptual understanding. But when you talk about boards, you need to give those descriptive answers. You need to know those theory points, some names, some phenomena, the scientist names, the definition, the units and all those things. So examples, applications, uses, right? Categories, classifications, all those things become very, very important. Diagrams, right? So that's why you need to go through the entire NCERT properly, because board's exam is completely through NCERT. Remember that. Yep, answer is 90 degrees. Phase difference between voltage and the current. Voltage is like this, current is like this. The angle between them is 90 degrees, right? So it is 90 degrees. Yes, voltage and the current through the inductor, 90. The vector sum of resistance, inductance and capacitive reactances is known as the circuit's overall. What is that overall property called as? Yeah, come on, think. What is the answer for this? What is that circuit's overall? See, resistance is in ohms, reactance is also in ohms, but the difference between resistance and reactance, do you know what it is? Resistance causes heat loss. Reactance does not cause that heat loss. That's why you give a different name to it, although the unit is same. Although the unit is same, we give it a different name to it. Same way, Resistance and reactance are two different names given to the resistances or opposition to the flow of current in AC. When you combine them together, resistance and reactance will give you impedance, Z of the circuit. Yes, the Z of the circuit, impedance. Z is the resultant of resistance and reactance, is the hypotenuse of the resistance triangle. The three losses in a transformer are dash, dash and dash. What are the three losses? If you don't know it, you might miss 2 marks question or you might miss a 3-mark question. Explain the losses in a transformer. What are those losses and how do you prevent it? And usually in a everyday transformer, what is the loss? So there might be a 3-mark question or 2-mark question in your board examination as well. It could be also a part of your JEE exam. Yes, there are 3 losses. One is the flux loss, second one is the eddy current loss, the third one is the hysteresis loss. Exactly, very good, Jack. Proud of all of you who gave the correct answer. Right, flux loss is where the magnetic field lines go outside the transformer's core, so there is some loss of the flux. Eddy current loss is created by the current loops which are formed in the core, which create heat. Hysteresis is created by the ferromagnetic property of any material when you magnetize and demagnetize in the alternating current cycles. Very nice. Hysteresis loss in a transformer can be minimized by using what core, and eddy current loss can be prevented by using what? How do you prevent these losses? How do you prevent these losses? Yes, hysteresis loss can be prevented by using a very good ferromagnetic material. Yes, don't use diamagnetic or don't use paramagnetic. You use a ferromagnetic material with a very small area in that BH curve. With a very small area in a BH curve. So you need a soft iron core which has a very small BH curve, and eddy current loss is prevented by laminating the core. There is a lamination which is given to the core which prevents the eddy current loss. Very good, very good, very good. Turns ratio for transformer is dash to dash. Turns ratio N1 by N2, turns in primary by turns by secondary, is V1 by V2, which is primary voltage to the secondary voltage ratio. N1 by N2 is V1 by V2, which is I2 by I1. Remember that. Current wise it is opposite, voltage wise it is directly proportional. Yes, very good. Some of you are really very quick here. Awesome. Should we do only NCERT questions for boards? Obviously, NCERT questions and PYQs. Two main things. Just don't do NCERT. That is not going to help you. You should also use your refresher or digest or those books, whichever you might be buying. You might know that already. Second thing, third thing is the PYQs, which you must do. These are main things for cracking the exam. Okay, NCERT is must, whether it is in-text problems, whether it is back exercise questions, whether it is summary, whether it is points to pointer, whether it is definitions, experiments, tables, charts, diagrams, whatever. Okay, reactions, etc. Formulas, derivations, all those things. Very important. Second thing, like I said, your previous year papers from either the school and even the actual board papers. Third thing is you can use your refreshers and digests and so many other books that you get in the market which are specifically made for boards. Just do that. It's more than sufficient to get 95%. If you skip the third step also, even if you do PYQs and NCERT, you will still reach 80 to 85% easily. Easily, I'm saying. If you put in little bit more effort, easily 90%. Next one. Inductive reactance in an AC circuit increases with increasing dash of the AC signal. See, inductive reactance. What is inductive reactance? It is omega L. Inductive reactance is omega L. So, if you want to increase it, you need to increase omega, which means you need to increase the frequency. So, you need to increase the frequency of the AC. That increases omega L, which increases the reactances. Yeah, 5 years PYQs are enough for now, because you can't do more than that also. I mean, it is really difficult. So, it's okay. The loss due to ferromagnetic material used in the core of the transformer is, what are the losses due to non-ferromagnetic material which is used in the core of the transformer? When you use a dia or a paramagnetic material, what happens is the field does not go only inside the core. Most of the lines are outside, So it causes a lot of loss in the terms of flux. So flux losses are very prominent, very dominating. Definitely Aki the Beast. I would be very proud and I will be waiting for that. Okay, not hysteresis losses also occur, but you know, even if you use a ferromagnetic material, still the hysteresis losses, although they minimize, they might not be minimized fully. You need to also minimize the area under the BH curve, like I mentioned before. It should be a ferromagnetic material with a small area in that BH curve. Only then the hysteresis losses go away. If it's just ferromagnetic but a large BH area, then it will not reduce. So when it is ferromagnetic, it ensures the flux comes inside. There is no loss. Alright. When the BH curve is less, then you will ensure that the hysteresis losses are less. When you laminate it, then you ensure there are no eddy current losses also. Okay. Unit of inductance, the dash, is the symbolized by dash and represents the inductance in a circuit when how much current should pass to produce how much thing. How is the flux defined? The unit of flux, sorry, unit of inductance. Mr. Beast, there will be more classes. These are not just enough. These are mandatory classes. Apart from this, there will be board specific classes during your board exam. So just before your English exam, we will have some English class. Just before your chemistry exam, we'll have chemistry class. Before physics class. All those sessions will also be done on this channel, but just before the boards. Next week, we'll be doing very precise JEE sessions, which will help you in your boards, but we are going to do some, you know, previous year's papers also, and we will do all the most repeated topics which are of 12th standard. Okay, 12th standard important topics questions. Let's do that. JEE specific, what say? Let me know in the comments also if you are watching this as recorded. Yeah, it is Henry. H is the symbol. Henry is nothing but 1 volt is induced by the change of current at the rate of 1 ampere per second. Henry, yes, H. If you pass 1 ampere of current per unit time and change the current by 1 ampere per unit time, which is 1 second, and 1 volt is created, then it is 1 Henry. Perfect. The capacitive reactance in a AC circuit decreases with increase in the signal's what? What do you need to increase? What do you need to increase the capacitive reactance? Come on, think about it. Capacitive reactance, capacitive 1 by omega C. Think about it. I think it should not be increase, it should be decrease. This is not increase, this should be decrease. Reason being, this is not increase, this is decrease. Because capacitive reactance is 1 by omega C. 1 by omega C. So the capacitive, oh sorry, it's decrease, my bad. It's not increase, then it is fine. Yeah. So if you want to decrease the capacitive reactance, then you increase the omega. Perfect. This is okay. No issues at all. Got it? Shall we go ahead to the next one coming up on your screen, and here it is. Very good. A device that stores electrical energy in the electric field commonly used in AC circuits for filtering or tuning is known as a device which is used for filtering or tuning. What is it? What is it? Come on, come on, come on, come on. Yes, that is called, you might have seen, rectifiers always are followed with a device, that is capacitor, to reduce the rippling effect. The rippling effect, to even out the ripples of the DC and to stabilize it. To make it a constant DC, you use a capacitor so that you can convert that AC to DC into a pure DC without any variations or fluctuations. The rippling effect is removed. So that is a part of semiconductors though, but still you should know about it. The EMF which is generated by a generator is given by dash when a coil rotates in a uniform magnetic field. What's the formula? The way to remember this formula is to remember a biscuit, which I think many of you will like. It's got that brown cream in it. It's got some sugar particles. The biscuit is brown, long, triangular shape with some holes in it. What is that biscuit? Bourbon, right? Bourbon, Bon, B-A omega N, that's all. Bon sine omega T. Bon sine omega T, right? Everybody should know it. Perfect, perfect, perfect. Sir, I'm from Sri Lanka. I tried to join the crash course. Can international students join the course? Because there is no way to make an account because I can't get an OTP. Yeah, you can join because there are a lot of international students obviously who are a part of it. How to get the OTP? Can you do one thing? Can you just write a mail to vcare@vedantu.com? vcare, V without any space, everything small, without dots or hyphens or underscores. vcare@vedantu.com and put in your email ID and just mention you're from Sri Lanka. I want to join this crash course. I was watching this Vedantu JEE English channel. Shreyas sir told me to write an email to you and I want to enroll. That will be sorted. Okay, please do that. Moving on, LCR AC circuit. The voltage across L and C are dash phase. Oh, come on. No, it is not NBA. NBA is for another thing. That is for your sensitivity formula for galvanometer. That has that basketball kicking, all those things are there. That is for different thing. Come on. What is the answer for this? What is the answer for this? Tell me quickly. LCR, voltage across inductor. L means love. Love is above all. That's how you remember it. So if L is above all, C is below. L and C are opposite to each other. So they are opposite, out of phase. Pi radians out of phase. That's the answer. No, not 90. Not 90. It is 180. Yes, Virat Kohli, very good. It is not 90. It is 180 degrees, which means out of phase, pi radians. If you take only resistor in a AC circuit, then the current and the voltage, well, there is no inductor, there is no capacitor. The voltage and current will vary together. There will be perfect sync. They are having zero phase difference, which means in phase. The answer is in the phase, 0 degrees. Yes. Sir, I am from Nepal, but I got OTP by healthcare of Vedantu. Oh, Virat Kohli. Wow, very nice. So, I think there was one student from Sri Lanka. I didn't read the name right now, but I'm pretty sure your issue will be resolved just like how Virat Kohli issue was resolved, and he's from Nepal. I am so happy. We have Sri Lankan and Nepal students, and I'm pretty sure there are many students from other countries too. Really happy to know this. The average value of AC sinusoidal current is AC sinusoidal current is what is the average value of AC sinusoidal current? What is the average value of the AC sinusoidal current? Whatever positive is there is negative is there. Negative, positive cancel each other. Average value will be 0. Very good. Excellent. Moving on to the next question on your screen. The galvanometer which is converted into ammeter. Obviously, you can convert a galvanometer into ammeter. And if it is used to measure AC current, which value will it measure? Remember, there are many things about AC. One is your RMS, one is your maximum or amplitude, then max to max, V peak to peak. Then you also have average. So many parameters are there. So which exact parameter does it measure? Now see, galvanometer is a deflection based instrument. Deflection meaning if current passes this way, it will deflect this way. If current passes the other way, it will deflect that way. When you pass AC, the current is changing the direction, very fast. So once the galvanometer will try to deflect this way, immediately the current would have changed the direction and it will try to deflect the other way. Again, it will try to deflect the other way. So what will the galvanometer do? The coil, it will keep on deflecting like this, but it will so fast, it will not end up deflecting at all. Before it tries to deflect, it will change its mind. And before it changes its mind, it has again changed its mind. So it is very fickle-minded. It will hardly get any time to deflect and it will just stay there. It will not move from 0. It will measure the average value, which is 0 again. So you can say 0. No, it is not RMS. Who measures RMS? Hot wire ammeter. Remember this name. Hot wire ammeter measures RMS current in a AC. Yes, definitely. Harshikesh Jalkote, definitely you can watch it for state board exams also. It is almost going to be the same portion. It's not going to be like ड्रास्टिकली न्यू. ओके, तुम्ही डेफिनेटली बघू शकता. ठीक आहे, बघा हे लेक्चर आणि बाकीच्या लोकांना पण सांगा. ओके, मूविंग ऑन टू द नेक्स्ट वन. द पॉवर फॅक्टर in an AC circuit is defined as the power factor. What is it? Cos phi. What is phi? Phase difference. What is phase difference? It's the angle between the voltage and the current, right? That's it. So it's the cos of phi. Phi is the angle between the voltage and the current, right? Perfecto, perfecto. Yes, I'll be bringing that NCERT solution. I'll definitely let you know what it is. Just give me some time. Yesterday the announcement came and we could not do that, but I'll try to keep that video either today, maximum by tomorrow morning. Okay, average power in a AC circuit. I is RMS current, R is resistance, P is I squared R, known as the dash power. Many students do not know this answer. Let me tell you, you will definitely struggle little bit to mark the answer. Do you know what is the answer for this? Power formula is I squared R. I is RMS current, squared R. But yeah, you can also write cos theta as R by Z, AHM, definitely. What is the answer for this? It's called as what? Reactive power, real power, apparent power. Well, it's real power. In fact, there are three kinds of power. If you remember, there are three kinds of power in a AC circuit, and that is given by a power triangle. If you remember, this is phi. This is VI, which is also called as apparent power. This is called as apparent power. And then you have the cosine component of it. So VI cos phi. This is the actual power which is lost. This is the actual power which is lost. And then this component is opposite to the theta or phi. So it is VI sin phi. And this is called as reactive power. This is called as the reactive power. This is a power triangle. This triangle everybody should know. Somebody is saying horsepower. Akki the beast. Which horsepower, man? It's called as horsepower. No, my dear kid. No, it is not called horsepower. Horsepower is 746 watts. Okay, definitely not I squared R. It's called as real power. I don't know if the option will be there, horsepower. And you would have marked the horse. Right? Okay, fine. That is not the answer. Moving on, the dash law states that the induced electromotive force in any closed circuit is equal to the negative of the time rate of the change of the magnetic flux through the circuit. Oh my gosh, what a complicated statement, but it's such a simple answer. Always, captain is supposed to lead from the front, definitely. Yes. Think. Come on. What is that? One simple law, man. This is not Lenz's law. No. See, E is minus d phi by dt. This is what it is. It is Faraday's law. Exactly. Faraday's and Lenz's law combined together, you will get E is minus d phi by dt. So this big thing is nothing but d phi by dt with negative sign. That's all they wanted to say. Correct. Oh, very good. Awesome. Dash currents are induced circulating currents within a conductor exposed to a changing field by magnetism, causing dash kind of losses. So if you pass changing magnetic field in a conductor, there are some currents which are circulating inside that conductor and they cause some kind of losses. What kind of losses and what kind of currents are these? Lenz's law is also correct. Both Lenz and Faraday actually. Devadarshana. So these are filling the blanks. So actual answer will be Faraday's and Lenz's law, not just Faraday's law. Yeah, both together will be correct. Okay, both of them together. Perfect. Yeah. How can moving charges create electric field? And OMG question. Moving charges can create electric field along with magnetic field. Anyways, a charge will create electric field. I mean, that is not a surprise. The surprising part is a moving charge can create magnetic field because a moving charge is like current. Current creates magnetic field around it. So charge just creates electric field when it is stationary, but when it is in motion, it creates both kinds of fields. Oh yeah, it is eddy current loss, and eddy currents cause heat losses, power loss, energy loss, any kind of word. Don't stick to this. It can be power loss, energy loss, heat loss, all words will match over here. Depends on what is there in the option. Next one. The power in a AC circuit can be written down as P is equal to dash, where cos phi is the power factor. In terms of power factor, how do you write it? In terms of power factor, how do you write the power loss? P is equal to voltage into current into cos phi. What is that voltage and current? RMS always. VRMS, IRMS, cos phi. VRMS, IRMS, cos phi. Cos phi is the power factor. Okay. So those are the questions. Be a part of the Telegram channel to get the latest updates. The moment anything happens, I will let you know. Don't waste your time Googling, YouTubing, finding what is that teacher saying, one teacher is saying this, so that's why we don't make so many videos also. If you realize if there is something important will come. So please don't waste your time. When NTA will release, we will come. But for that, you be a part of Telegram channel. Link is there in the description box below. And yes, you'll get PDFs and other notifications too, which are purely academic, which are going to be useful for your exams. Smash the like button for your Captain Shreyas. Be subscribed to the only JEE English channel in the country. And for the best of the best content, be tuned on to the channel. Thank you for loving, thank you for liking, and I would love to see your comments down there below. Thank you so much. Thank you so much. Okay. Bye bye. Take care. Have a great time. Hasta la vista.